exactly twice as much as the plus and the minus, in cases where you might be extending ratios out and you get like a plus plus, instead of having two plus signs, you could just use a greater than sign. Or vice versa, instead of two minuses, you could have a less than sign. So it simplifies things a little bit. And I show an example, like where it says example, if you scroll down a little bit, and I explain exactly what it would be in just intonation. This 42 to 25 ratio is B double flat less plus plus. The period is not part of the notation here, it's just the end of the sentence. But in 72 EDO, you know, it just becomes plain B double flat because everything cancels out just because of the way 72 EDO works.
Okay.
And then
Plus makes greater than,
and
and then 2 greater than makes,
One less than, one greater than cancel out. 2 plus plus is greater.
yes, and then 2 greater is B. Or not?
Well, no, it's a less than, which is 2 minus, and you also have 2 plus, so it's
Right.
equivalent, so they cancel out.
Right. And if you're really simplifying things,
Yeah.
if you want to, you could just call it A instead of B double flat.
Yeah.
Because
yeah, and harmonics were
Because in 72 EDO, B double flat and A are going to be the same note, so it really does simplify all the way down.
I see.
But for notation purposes, a lot of times you might want to say B double flat. But in any case, in that tuning, it's still the same note. Just like in 12, B double flat and A are the same. Okay, but now that gets back into the question that Andrews asked about EDO too. So can you scroll up to the index and go to, under E, I have a thing called EDO prime error. And on this page, I have a whole bunch of graphs of different equal temperaments showing how, up to the 43 limit, showing how well or badly they approximate that prime number, that prime factor. And in this case, I'm showing only the absolute value. So it doesn't show whether it's too big or too small. It just shows the amount of error. And what I mean by the error here is that it's the percentage of each step in that EDO. So if you look on the left side, I have the reason why I put these numbers in the order, I'm not talking about on the picture, I'm talking about all the way on the left. I show you the prime and then how many degrees of the EDO that prime maps to, and this is not like within the octave, this is totally how many degrees you need to get to that prime factor. So like for instance, let's go to 12, because 12 is what we're all familiar with. So in 12 EDO, obviously prime 2 maps to 12 degrees, and there's 0 error, and there's 0% step error, which is a relative error. Prime factor 3, which means the 3 to 1 ratio, doesn't map to 7 degrees, it maps to 19, because it's an octave plus a fifth. But it's still, because this is an octave equivalent idea, it's still 2 cents error roughly. To 1 decimal point, it's 2 cents. And then it's because of the definition of cents as 1/100th of a 12 EDO semitone, it's minus 2% step error. Now on the graph, you don't see that it's minus 2, you just see 2, because I'm using the absolute value, just to compare how well it approximates all these primes.
And if we add the sum of the relative value of all of those, then we would come up with something like badness.
Yeah, exactly, exactly.
Average, no, yeah. But the total error would maybe be useful. Yeah,
Something like that, yeah. I don't really know about badness that well myself.
No, but badness, again, badness seems a little abstract. But if we had a total number, it seems like average would also
Well,
be useful, but yeah, a total number would indicate how well that EDO system approximates JI and would be a useful number.
Mhm.
give us some
lower the number,
full
the
idea
more.
of some kind of, not statistics would be bad with, but some kind of
But isn't it,
experience.
isn't it then a bit similar to tennis, harmonic space?
It probably is, it probably
calculation,
is.
or I don't know.
Yeah, and Clarence Barlow has this thing too, indigestibility. I mean, there have been lots of these ideas before, but I was not really part of the discussion of what was going on with all of that. I mean, it got really mathematical and, there were things in my life too where I was not really on the team. But this is what we're really familiar with. We know that 12 EDO represents 3 really, really well. And 5 is not so bad. It's not great, but it's not so bad. 7 is really not that good. It's not good enough to really give you the indication of the 7th harmonic. It's far enough away that it doesn't really sound like the 7th harmonic. And then of course 11 is almost exactly in between 2 of the degrees, so that's as bad as it can get. So 50% error means that it's exactly in between 2 of the EDO degrees, and that's the worst approximation you can get.
So maybe let's go to 22.
Exactly.
Because,
So
that
in
is,
22, you see 3 is much worse than in 12,
Yeah.
But 5 is much
but
better.
5 is much better, 7 is quite a bit better, and 11 is a whole lot better. Mhm.
And then 31 is amazing.
Right. When I told you guys the other day that the interval that's a quarter step less than an octave is almost exactly the 31 to 16 ratio. You see it right there. It's really close. 0.4 cents error and only 1% of a 22 EDO step.
That's it.
And now go to 72. Scroll down to 72, please, Hans, and I can talk about Hume a little bit more.
Result of our days of contemporary music. Now we all go in some
72.
chorus and
72.
That's
Yeah, I don't have all of them.
Not
There's
too bad.
there's some gaps. There you go. So 72 it's fairly good for 11 limit, and then after you get past 11, it's not as good until you get to 37. But
You see a fairly good 3, 5, 7, 11.
yeah, the way I mean, it's close enough. It's close, and of course, as the numbers of the EDO get bigger, you know, the cardinality, of course, the absolute value gets lower and lower and lower all the time. So if you look at the sense error over on the left side, there's nothing on here that's greater than 8 cents error, or even just barely more than 7 cents. So the error in absolute terms is still pretty good. But in terms of consistency, the relative error becomes important because, for example, you know, if you try to use 13 in 72 EDO, your spelling is gonna not make sense because how many well, I don't even know how many steps it is in 1 octave because I have it here for the whole 13 to 1 ratio. But however many steps it is, if you do that again, then your error is gonna mean that another step smaller than that is actually a better approximation. So that's what the consistency means. It means that
Yeah, of course, it's just, we can maybe very quickly imagine if we have pure force in 12 EDO, that's very good. C, F, B, E flat, and so on. Very good approximation. But if you want to now use the 11 over 8, what is a quarter tone below this? Big quarter tone more than a fourth roughly. Then of course you can approximate that they don't. This is so in a well you don't know if they approximated with a fourth or with a tritone, and so if you take 1, then you get with the next step the error is so huge it's not anymore than what it should be.
And so I don't know if you want to look at any more of these. I've talked a lot about 270 EDO as a possibility for replacing sense, not necessarily to use as a tuning for music, But you can see that in the 13 limit, this is a great alternative to sense because first of all, it's one digit less. Instead of 1200 is your maximum, you only have 270. And the error is so low that all you need is those 3-digit integers, and you can add and subtract all you want, and the rounding error is not going to amount to that much. Because in the 13 limit, the maximum error is 12%. And in 11 limit, it's even better. It's only, the maximum is,
5.
well, it's 5 for 11, but yeah, for the 5, it's 8%. The maximum error in 11 limit is 8%. So that means you can you can add and subtract these EDO degrees, or if you're thinking of them as ratios, multiply and divide the ratios a whole lot before you deal with any rounding errors. So that really would simplify things a lot. But, you know, the world is stuck on sense, so I don't see this really happening, but it's a possibility. And then 311 is another really interesting one. Scroll down a little bit to 311. For the same, to use it for the same purpose, but here you have terrific approximations all the way up to the 41 limit. So, in terms of the amount of error, you know, this is not as good as 270 in the 13 limit, but if you're dealing with 41 limit JI, 311 is really amazing because it gives you 24% or less error for every prime factor up to 41. So then, you know, the other thing is, like, where did EDO come from? I actually remember this. This was in the tuning list discussions where Dan Stearns, who's a microtonalist from Boston, or he was then anyway, he said he was writing pieces that combined EDOs actually, and he's the one who said, I personally don't think of them as temperaments, I just use them for what they are, equal divisions of the octave. And that's where I came up with EDO. I think I invented that abbreviation. I don't know if I did or not, I think I did.
I think before it was widely used, ET, equal temperament.
ET was always used, right.
T or TET.
Right, exactly.
N/TET.
Right.
And that what I learned it first in, I think 2007 or something like that in Hamburg. So when they talked about Georg Heider, Manfred Stark, if they talked about that, in that time they talked or wrote in their articles about TET, and then few years later, the EDO came out, and I think I read it somewhere in the internet, and then of course the recent replacement of the, if you even say we can replace the octave by another interval, then
Right.
replaces by the ratio, like then we have ED3 for
Volumpeers.
Ball amperes, like or I sometimes I don't know if I have seen that or if I now generated by myself together EDT, if you say ED tritaf. So
Well, at that point, I had already started putting together the encyclopedia. This was like around 1998. And I just thought, well, if people are going to look to I don't even think it was called the encyclopedia yet. It was originally the Dictionary of Tuning Terminology or something like that. Dictionary of Tuning Terms. And I thought, if people are going to be looking to this as a reference, then maybe I should say something about this difference between whether an equal division is representing just intonation as a temperament, or whether it's just being used for what it is, just equal division of some number. And so, I'm sorry about any problems navigating. My website really needs some maintenance. You might not be able to reach menu items. A lot of times if I have this problem where they appear too far away, I just right click and that opens up some sub-menu, and then I can scroll to where I want to.
Or just to reload it?
No, it's a problem in the code on the page.
Yes.
I mean, this encyclopedia got so big now that I really, it's gonna be a lot of work to clean it up.
Yeah, this is the way like how it was before TET or
Mhm.
19 tone equal temperament, and the problem is if you say equal temperament, it was of course by it was for granted that it has been an octave, and with
Right.
recognizing the polar beer scale. So what to do? How we see it? We cannot. If you say a certain tone equal temperament, even polar beers is a certain tone
That's
equal
right.
temperament,
That's
and
right.
then you got the problems with terminology, and then it came this EDO, and then you can use the O replace with whatever you want. Okay, Andros.
Maybe we finish now. Yeah. We have a lot of, actually, I started also for my brain or for more understanding some kind of ontology of these terms, but it is not now necessary because we have talked a lot, and brain also needs some relax.
Mhm.
And also some, I personally have to go to interpreters to help some things and etc. And we need also maybe some program, paper program. So now we have to make something. So thank you for all. The great explanations. Yeah, I like that. We have here some type to cook this soup. In some place, so it's good one. I gonna make this.
All this stuff put together and.
This was a lot of work. I spent years working on this.
Yeah, but it's never actually finished.
Right.
Because I like Wikipedia, because I see that, okay, some things stay in the same level as in 2010, for example.
Mhm.
But now in 12 years, in some 10 years, come some new ideas and articles start to develop. So that it's strange, but I like this kind of collective. But when you sit in your it is also very important because you make huge work and so and so. But in some moment, maybe it would be good to put in some wiki-like system and let try to be collective way to develop this.
This encyclopedia is the reason why my book never got finished. My book is still not really finished.
Yeah, but
That's why.
this kind of
People
things
start
actually
to do
take thousands and thousands more time as you
Right.
as in starting point things. And,
And you're the only contributor here, or?
Well, I used to quote things from the tuning list, so a lot of articles in here will have, citations and quotes from what people wrote on the tuning list, but I'm the one who put the whole thing together.
Okay.
Yeah, I mean, I got permission, I asked Paul Ehrlich especially because so much of his stuff was so important. I said, can I